you have to visualize something, like we'll try to minimize what we have to visualize. That makes it better. So there's less glare. I think there's less glare.
It looks like there's less glare.
Sometimes someone from not from my class requests, can you make the videos more clear? Maybe yeah, we are recording. Okay. You know it's bad when a professor says that. Yeah. She is right. She just presented to the IWCR group.
You're getting 100. I'm calling it. No, I'm calling it.
No.
No. Megan's gonna get 100. I'm calling it.
Okay. Right. Okay, so here it's mostly algebra, but you do have to kind of visualize what you're seeing. And the things that you'll need on a sheet somewhere is the coordinate changes, which I never remember them, but they are, well, the one that I do remember is this one. That's one. And then you have x is equal to rho sine phi cosine theta. Y is equal to rho sine phi sine theta. And then you have z is equal to rho cosine phi. And then you have dv, rho squared, forget it all the time.
Is that negative?
Sine phi. Okay, where's the negative?
The y, the bottom.
No, there's no negatives.
No, sorry, like in the actual integral. The second.
Yeah, that's the negative. Yeah. All right, you can do this two ways. One way is, well, I think the easiest way is to actually look at what you have. This to this part here, if I square this out, this is a sphere, but it's telling me that my bottom surface is z equals 0, and this is, if I square it out, I get, so deal with surfaces first. Square out top limit. And you'll see z squared is really 1 minus x squared minus y squared, and I get z squared is equal to x squared, or z squared plus x squared plus y squared is equal to 1. So another way to think of this is that you're going rho equals 0 to rho equals 1, right? So what you have is a sphere. And because this is only positive, not a negative, I don't got the whole sphere. This already relegates this to being a hemisphere, half of a sphere. Otherwise, I would have to go from minus square root of, this forces it to be half sphere, a half of a basket. I just sliced a half of a basketball. Good?
Good. I'm confused on what C means. Is C just like a like it's not up here, but like, is C just a constant?
Where's the C?
I don't know. I was like looking through notes and I was kept on seeing C. It was like rho equals C, theta equals C, the theta with the line equals C.
Show me, okay? Because I don't know what that is. But so far so good. This is just half of it. This part here represents half of a sphere, the top half. This part here is your XY plane, right? So you could actually make a picture. So far this part good, right?
When we're squaring the top limit, how do we get 1?
Because if I square both sides,
That's a 1.
it's a 1.
Oh, sorry.
Wait, so the reason why it's only the top is because it's cut in half.
Yeah, if I had here minus square root of 1 minus, it would be the full thing, right?
Oh, okay.
Okay, so I have just the top part of the hemisphere. So, but the next part here tells me what the shadow region looks like on the xy plane. So what I have on the xy plane, if I just graph this part, is this is the bottom part of a circle and this is the top part of a circle. Like that. But then I'm forced here for x to be 0 to 1. So this forces it to be just this part. So I'm just getting on the shadow region, this part on the floor. This is the full circle. This forces it to be on this side, right? So this is what I got on the shadow region. So the shadow region applied to this, there's a shadow region drawn on there. It makes it so I don't really have the whole hemisphere. I just have this part of the hemisphere. So I can tell you what that surface looks like from this information. So far, so good?
But you would only know that by square. You would square the.
I would have to recognize that this is part of a sphere. Mm-hmm. So, like, yes, I would have, you know what I would do is on your formula sheet, I would have z equals plus or minus this, or I would have this version, right? I would have both of these things.
And a quick check on when your meeting is going to be over, because I haven't had a really short question.
Okay. Let me pop in after I finish this one.
Okay, great, thanks.
But it's a spherical coordinate one, so it might take some time.
If he has to run, I'll build it to you.
All right, so check that this is the hemisphere. This part here forces it to be just this part of the hemisphere. So I sliced a basketball. I have a basketball. I keep looking over it. And you guys, why is she looking over it? If it was minus square root of this up to the positive square root of this, it would be the whole basketball. I just sliced it right along here when I did z equals 0. Z equals 0 is halfway through. So I don't have the bottom half of this basketball. I just have the top. And then I said the shadow region is this part here. Well, that means that for the ball, I have just this part of the top hemisphere. Because that's like the intersection of all this is just the top right part of this.
It wouldn't be the bottom?
No, to be the bottom, I would have to have z equals minus this. I would have had to have this.
Minus the whole equation.
Yeah, right. That's how you get top and bottom of the whole sphere. But because I made it z equals 0 is the plane.
Yeah.
That just sliced right through.
Wait, so that's not the shadow, but that's not considered the shadow?
No, this is just only the surface. The first one's surface to surface. So the surface one is the plane z equals 0. Surface 1 at the top is the top part of the sphere.
Yeah. So when you like shoot through,
right?
It's like, okay.
Exactly.
What did you say about the shadow region?
Then this part here, these two.
Oh, and it's reflected on like the YZ.
Yes, and so this says the rug underneath this, where it makes the shadow, is this. So I really don't have the whole hemisphere. I'm relegated to just the top quarter. See it?
Yeah. That makes sense.
All right, awesome. Okay, now if I want to switch it to spherical coordinates, the easiest way to do it, now that I know what I'm dealing with this part of the hemisphere right here, right? This is what I'm dealing with. Mm-hmm. I can now say I have 3 angles to figure out. So I did use this one a little bit, but this is my z-axis. Tell me when to stop when it's not in the picture. Right there, right? So how much of an angle did it drop by? If this was 0, pi over 2. So my phi goes from 0 to pi over 2. What about my rho? what's the radius of this thing, of this ball?
1.
1. So it's 0 to 1. And then the theta would go from what to what?
It would go from pi over 2. Oh wait, but we're going the other way. So pi over 2 to negative.
Negative pi over 2 to pi over 2. But you probably would get the same answer because it's symmetric. But I told Andrew, fighting for your points back later because they said, well, you'd have to come back and argue that you actually knew that that was the same answer, right? It's going from minus pi over 2 to pi over 2.
Yeah.
Because you always go counterclockwise. And then the dv would be this business over here, this rho squared sine phi d rho d phi d theta. And if you understand this, then I think you'll be fine.
And do you think that maybe it'd be a good idea on somewhere on our sheet to be putting what, like,
Sure.
I don't know what they're exactly called, like theta, p, and like rho? Would it be a good idea to say what each of them mean?
Yes.
What them
Yes.
represent?
The drop in rho. How far can rho go? Rho can start at 0, and what's the longest drop it could possibly have?
2 pi. Well, isn't it like rho can like literally make a sphere because it's just like everywhere?
Rho-
It's just the point from the origin.
Rho can go here and end up at the most it could go is drop down to pi because it's from the z-axis, right? So it only can drop as far as pi. So somewhere between 0 to pi, your picture stops.
Wait, I have a question then.
Let me pause and finish up with this one, and then I'll just shut this off. Good?